Okay, so by show of hands, how many of you have what you consider to be a legacy application at your place of work? Has anyone not put their hand up? Because you are probably a liar. Or you're fortunate enough to work for a startup that is like genuinely greenfield, and I think everyone else in the room envies you. So, out of those people that have legacy applications, how many of you do not have any maintainers or committers for those projects anymore, that no one in your company has worked on them? A few people that admit it. Good. All right. So out of those few remaining people, how many of you genuinely could not redeploy that application if it went down? You'd have no idea how to rebuild the infrastructure, any idea how to redeploy what's actually on it. So you're kind of stuck in this situation, right? Bit of a pickle. I know I was speaking to some people yesterday at the Open Spaces talk, which was kind of eye-opening for me because my grasp of what legacy is does not extend as far as mainframes. So apologies to anyone, like if this is not made in my lifetime, and I'm not that old, I cannot help you. So this presentation is not about a lot of things, not because I don't care. I partially care. I'm not going to praise to you any specific orchestration tool. Like, this particular demo uses the easiest viable path for showing you what I'm about to demo. For example, we don't use Kubernetes at my place of work. We use Nomad. There are reasons for that. As Renata kind of slightly touched on, it's not necessarily the banhammer that you need to get everything out. I'm not going to tell you anything about culture, because I'm British. I'm not the most cultured person. I'm not going to tell you anything about proxying, service meshes, any of that stuff, because it's not really relevant. And I'm not going to show you any dashboards, because I do not like dashboards. Really, this talk is about something that's kind of key to my heart, mostly because I am basically the garbage man of most companies that I work for. I'm the guy that has to clean up a lot of the messes. Not because I'm specifically skilled at that, I'm just a sucker. So why would anyone want to migrate their applications into containers without writing any code, you might ask? Seems like a ridiculous proposition, because most places that I've worked will look at their application code and go, all right, there are some libraries that I can put into this maybe, if I'm lucky, and I compile this, and I reroute that, and then I can hook into this, and then I've got server discovery. All right, that's great. You might be able to do that. What are the risks? What are the risks of you trying to modify something that you don't truly understand, and in particular systems that you've got that are mission critical? Like, I worked in ad tech for a while. There's a whole bunch of code that's related to how you handle tracking. Like, horrendous. PHP 4 stuff was in use up until a year or two ago. Like, would anyone touch it? Would they hell? Like, I think one person broke it once for about 5 minutes, and we lost 6 figures. Like that. Like, it's not ideal. So no one wants to do it. Everyone's got better and more interesting things to do. I certainly do. I imagine that's why all of you are here. No one wants to sit here and SSH into a server that they can't install anything on or change anything on. Half the time, you don't really want to delve into that nightmare. You know, there's a lot of spaghetti code out there. Is it worth your time? Is it worth your company's time? Is it worth the risk? And in a lot of cases, as I know my bosses are in particular about, everyone wants to see that cost-saving benefit of containerization. How do we save money? How do we get onto Kubernetes and shut down all these servers, even though we probably need as many servers or more servers? One thing that's kind of true to an unnamed company that I won't work for, they were a Perl shop. What is your availability of hireable developers to maintain this kind of stuff? Like, can you actually hire the people that actually have these skills anymore? For example, again, touching on something I learned yesterday, what is the availability of COBOL developers? Not great. Or like, what genuinely is the availability of people that know like specific Java frameworks, specific older JavaScript frameworks? Like, how do people know how to work with some of this stuff? Could you get them? Could you even train them? Possibly not. And as anyone that started their career in the 2000s, like I did, knows that most documentation back then was flaming garbage. Like, so if you go back and look at something that was written by someone on a weekend project back in 2003, and think, how does this library work that like our revenue stream depends on? Is that going to be good documentation? I'm just saying. So the assumptions that I'm kind of making today, which is what the premise of this whole talk is built on, is you don't have the familiarity with the code that you want to. You don't have the time to work on it. And in a lot of cases, you might not even have permission to do it in terms of from your company, physically to get onto the box. Who knows? and you don't want to risk introducing bugs and the legal liability of potentially changing some code that has ramifications in that kind of space. Like I know some of you work in legal, banking. Some of this stuff, if you change it and get it wrong, there are consequences to that. And no one really wants to deal with that. I certainly don't. So the path of least resistance. Let's find one of these so-called legacy applications. And to just clarify my credentials on this, because you're probably looking at me thinking, this guy's too young. Doesn't know anything about this stuff. So I started my career as a Cold Fusion developer. Does anyone know what that is? That's good, because I was also a Flash developer. And spent over a decade as a PHP developer. And now, due to employment circumstances, I work in DevOps. So, joking aside, I've seen a lot of things, a lot of things in the mid-2000s about how things were done. Picked up a lot of projects where no one knows how the custom framework that was built works, and then the fourth and fifth version of that custom framework built works, and why those requests go missing, all that kind of horrible stuff. That's kind of where I'm coming from. So I'm going to go through this really quick, mostly because that's how I talk. I'm going to show you 8 live demos, the first few of which are not interesting at all. It gets better, bear with me. All of this stuff is in GitHub. So all this stuff will be in GitHub. I have videos that run through all of the 8 things I'm going to show you that I'll put online, so you can reference that back. The slides will go online, so if I skip over anything, or you're thinking, why isn't he talking about that? If I haven't gone into enough detail, either come find me, or a lot of the stuff, there are much, much smarter people than me who will explain things how Kubernetes, Consul, Vault work. And if I skip over anything on purpose, it's because I probably don't know. So let's find a legacy application. So we need to find something that's been designed pre-containerization, something that has no concept of running in a container, what that entails, what the boundaries of that are from application environment networking perspective. Must rely on some kind of file system-based configuration. I needed to kind of narrow this talk down to one particular topic because, frankly, there are so many things we can talk about in terms of legacy. So I would focus on the one where people say, I need to inject some kind of stuff into. No. Let's assume that these applications are possibly run on servers where there could have been 3 or 4 applications running, because people were cheap back then and servers were expensive. Like, you can't necessarily just have an application server that runs one thing. I mean, that seems common to us now, but back then, like, are you going to waste like this giant rack of stuff on a handful of applications? I was like, yes. And then my boss was like, I'm going to fire you. So I'm going to make assumptions about some other stuff, like a lot of these things assume that you have a web server and a database. Maybe an application server if you're lucky. But a lot of this stuff assumes that you have a single shared file system. Like, I'm going to write to here. I'm going to read it back from here. I'm not going to assume that this is network-based, or that the file system might change, or that the file system might not be there, and when I come back up, it's gone. These aren't concepts that some older software actually has any understanding of. And as DevOps, kind of the whole point of this talk is we can gloss over that stuff. We can build stuff around that. So let's pick an older application. As a PHP developer, and the thing that I possibly hate the most is WordPress. It's responsible for a lot of success in the PHP community, but it's also responsible for a lot of the things we used to get blamed for. So I had a look. Obviously, there's a Helm chart for it. Everyone runs WordPress. Really common. Not a great example. It's been done. So does anyone use forum software? PHP is an elderly, slightly raggedy piece of software, but it's used all over the internet. Like forums are the best place for people to chat all kinds of horrible nonsense about the things that they love and probably shouldn't care about. But hey, that's been done, because forums are forums. So I thought I'd pick another forum, which I'd never heard of, that kind of sounds like a rip-off of it, but relies on a couple config files. So I think, let's try this. So does this kind of ring any kind of true with anyone? First 3 years of my career, I genuinely didn't know what those 3 numbers meant. I just pretend to now, but everyone's been there. Everyone's gone into a web server and opened up wild permissions and wondered why their box got owned. I'm not going to say that I've done that or been caught by security personnel before. Hearsay. So, older applications live on. A lot of this stuff was started a long time ago. For example, MyBB was started back in 2005. This one, for example, is actively maintained. Like, people still use it. People still care about it. And that's kind of one of the kind of stories that I want to tell about this, is that just because software is old doesn't mean we should just gloss over it. Because although you might be thinking about all the new and fresh and single-page applications I can hook into my magic service mesh of 200 microservices, not all of the internet is like that, truthfully. Let's be honest. Like, a lot of our jobs is maintaining the other stuff and that horrible, painful transition journey of moving stuff across. And that's why I'm skimming over the culture aspect, because that's a whole different beast. But we have to deal with the reality that there is software, some of which is still being maintained, some of which is not, that we have to kind of actively keep up. And people are still reporting issues with software that is, coming up to 15 years old? I had a look at the code. It's rocky. But lots of stuff still gets posted. For example, these are the nicest ones I could find. But there's thousands, hundreds of thousands on posts of these. There's a whole bunch of information that people around the internet still care about. Discussions that are still ongoing about things that I'm not really sure what most of these are. But one of them is the Ford versus Chevy forum, which, as a European, I'm not going to comment on North American cars. Part garbage. But I mean, that forum was started back in 1999. They eventually ported it from its Ultimate Bulletin Board to like MyBB. So they went from one extremely elderly piece of software to another one which is somewhat geriatric. So like, there's a lot of passionate stuff that goes on there, a lot of people complaining about big block V8s, skylines. So majority of the file-based configuration in this application is in 2 files. Like a lot of applications in that kind of era, most of the configuration is loaded straight out of the database. So as long as you've got database configuration and the things that I most often need to check immediately upon startup, I'm going to load all that from the files. The rest of it, like what the posts, what topics are there, it's all coming from the DB. So as long as we can get this up with those 2 files, we're good. So config.php and settings.php. Why do they have different names? I don't really know. But the thing to kind of point out here, which is kind of extending to not all configuration is JSON or YAML files. As everyone remembers, it's not even INI or XML files, if you go back far enough. Like, this follows a flavor of a typical PHP pattern back there, which is you just write them as PHP data structures, because it's quicker to load, because you don't have to run a file parser over it, because parsing files back then was expensive. CPUs were slow. So in this file, you've essentially got environment configurations such as database connectivity, cache settings, really rudimentary firewall type blocking stuff. You know, we're going back to an era where no one had web application firewalls. No one was in the cloud. It's just, you go into the application, I'll run some kind of whitelist. No one's really getting attacked or DDoS that much back then, because no one has that many botnets back then. So, you know, we're going back to a much simpler time, a time where I felt smart. So settings.php has a bunch of kind of more miscellaneous settings. The key thing about here, which we'll come to later, is the application is responsible for generating this. So I can edit this, I can drop it into the container, but the application will update it itself, because that's how it expects the admin panel to work. So again, a lot of other applications in that kind of era, across all languages, will go, I'm just going to write this back to disk and read it back, because it's quicker than writing from the database, reading from the database, rather. So, and that makes sense. That made sense in that era. But now we're in a state where, am I necessarily writing to a file? Is it going to NFS? If I read it back, is that quicker than reading it back from the database? Maybe, maybe not. Depends. Depends on geographic locations, depends on multi-AZ. Again, stuff that wasn't really a consideration at this time, but something that we, like as DevOps professionals now, have to worry about. So, live demo time, the thing that I have been dreading all conference. And this is probably the least impressive thing you will ever see. So let's download a copy of the application. So no smoke and mirrors. I'm literally going to download it and install it. All right. Does this kind of screen look familiar to anyone? Let's go through, ignore that. I guess I agree. Basic requirements check. Looks like I've got thing like database extensions, blah, blah, blah. I don't care. All green, looks good. All right, so for simplicity, I don't have a database installed on here, so I guess, for the time being, I'm going to run with SQLite. The lights here are extremely bright, and I cannot really see. All right, boom. So let's go create some tables. Let's go populate those tables. I would fill this out. I don't feel like it. Use the most secure password known to man. I assume you can hear from the keycaps what I just typed. So there we go. All right. God, so bright. That's the one. So we have bulletin board software. Thank you. I'm kidding. So we're done. It runs. So what did we learn? Nothing. We learned absolutely nothing. This works on my laptop with a database that is on my laptop that runs in a tiny single file. It uses a local development server, which if you hit it hard enough, and I tried once, it'll crash. And SQLite is good for certain use cases. Good for caching local sets of data on your mobile. Is it good for running a forum on? I mean, probably it's not going to get any traffic, but regardless. So let's put this in a container. I actually don't know what's happening there. I found a bunch of GIFs and found a way to put them into my presentation, I thought. So first off, and this is kind of something, if anyone was at the open space yesterday, I was trying to touch on because it's one of my pet peeves. And it's not actually something I'm about to do, but it's something I want to touch on currently because it's something I've seen come up a lot. So how do you build the environment to run your application in? Most people are going to go, well, I program in Node, so I'm going to download a Node container. Or I run Java, so I'm going to download a Java container, just run it on that. But we, as DevOps professionals, and anyone here that's in security or is an old-time sysadmin, does anyone think that's a good idea? Probably not. Maybe if you are fully confident in the contents of that container. Do you know that all the packages in there are secure? No, you didn't build it. Do you know that the operating system that it supposedly runs on, like say if it's an Alpine container, is good? No, unless you're checking it. So anyone that has like a container image security scanning system, you're good. But do a lot of people actually do that? Do developers that want to get up and running really quickly actually take the time to check that kind of stuff? Not entirely. So let's just go over the real basics of, can we build a base image? What does that involve? So how bespoke is your application runtime? And this varies massively. Say for this example, this runs on pretty much bare stock PHP. You know, it was built for PHP 4, later 5, will run on 7, but some languages aren't backwards compatible like that. Ruby. So how are you provisioning your servers at the moment? And that's the one thing that I kind of want to promote here is reuse of the tooling that we already have. Like I find a lot of people will go, okay, so I've got this giant set of chef stuff over here, which I use to provision my environments, rock solid, fully confident about it. I can run it at 3 a.m. when I get paid, so I don't have to worry. I did all the work. Okay, I want to containerize my application. I'm going to write this 10-line Docker file. I'm pretty sure they're the same. That is not necessarily a realistic expectation for you to have to run software that is in this very, very carefully groomed garden here and is in a cactus here. So one thing to think about, and like I said, it really depends on your use case, is there any way to reuse all of the provisioning magic that we have now and just chuck it into a container? So this is an example. I thought I'd just chuck this in, see if it ran. Tried to run it, and this has a caching option, so I thought I'd run it with memcache. It does not work. The extension's not there. All right, well, I installed the MySQL extension in a single line. That'll look pretty good. I'll just install it with the same Docker PHP extension install command. Doesn't work. Why? Because the libraries aren't there. So a lot of Docker containers that are supposed to be like for the OS they're based on are much stripped back. So what do? I write that. Looks kind of nasty now, right? I'm pulling down a repository which I am Stack Overflow sure will work and it's secure. And I'm going to store some extra libraries, which, they look legit. I don't really know what that is. But I'm in DevOps, so people trust me, apparently. Then I'm going to configure it and install it. And memcache works. How happy I am with that solution? Not at all. But this is a demo, and I'm never going to run it after today. So you also potentially have file layer limits with Docker is something to bear in mind. I think there are ways around the 42-layer limit, but if you hit a certain point, are you just building 100, 200 layer file of all kinds of tiny incremental changes? Is that necessarily what developers want to pull down? Say if you change something in the base layer and they pull down a whole bunch of garbage. Or would you just want to kind of encapsulate that and package it all up in a way that they can get, which really is the whole advantage for a developer, right? You tell them, this will run this, looks just like this, just pull it and just get on with your day job. Like, so we can get on with our day jobs. So some people recommend using multi-stage builds or bakes. So you build like a base thing with base libraries, binaries, runtimes, put some other stuff on top of that, maybe sprinkle in your application code, maybe put libraries in, and layer it up. But then people obviously complain, and this kind of touches on the points I went about earlier. Like, what is your bare minimum? Like, is it necessarily going to be a tiny few set of things, or is it going to be a whole kludged bunch of stuff that you need to install to get your like Java 6 application to run under very specific circumstances? But the point is that doesn't matter. It doesn't matter what you have to put into that container. It doesn't matter if your container is a gig, 2 gigs more. I deployed 2 gig containers out. Doesn't matter. Yeah, it's a little slower. A little slower to deploy. Will it run? Sort of. But the point is, like, these are ways and means that you can do it, and I don't think people should look at them as a kind of barrier. Like, this container is fat. So? Like, will it deploy? Will it fulfill your requirements? Can you actually get it off infrastructure that you don't want to maintain, is about to fail? Can you throw it into some kind of container orchestrator and worry about those problems later? And can you like at least take advantage of some of the things, like the resiliency of it like automatically coming back up if it drops off, like basic health checks. Things you necessarily can't do if, say, like a VM fails and you can't easily reprovision it, depending on your use case. So, I mean, I'm assuming everyone's seen this. If you haven't, do you run Alpine? Have you checked your images? You probably should. But that kind of stuff happens all the time. Oracle, being the wonderful people that they are with the Java community, decided to pull their Oracle Java 8 images a few weeks back. We were building stuff off of them. They stopped building. So like a lot of people have already switched over to OpenJDK 8, but if you are pulling from community images that you do not have control of, it's the exact same thing about trying to pull APT or RPM packages. Like if it's not there anymore and you don't have a mirror of it, it might just disappear. And if you're reliant on that, if people are building like Yum repos to hold the kind of stuff that they know might disappear from the community, why aren't we doing the same with Docker? Why aren't we doing the same with container images? So, all the big boys now offer agentless provisioning. So this is essentially, like, as an example in my last job, I just built a CentOS 6.9 container. It was like for like the same as the VMs that we were rolling out. Like I said, kind of fat, but everything was in the same place. All the binaries in the same place, libraries are in the same place. Everything's configured, stock the same, which means I know, give or take, it'll run the same. So Puppet finally came out with Bolt. If anyone still has to use Puppet, which I do now. Chef was on top of the game. Salt has a mechanism to do it, and Ansible has always been able to do it. I'm personally a fan of using Ansible with Packer. Like that's my thing. But it depends. You could probably plug this stuff into, and you can use shell provisioners. You can use stack shell provisioners, which I spent, as Jason knows, the last couple of weeks agonizingly trying to get something working. But it doesn't matter. If it runs in a shell, you can get the stuff to work. One little caveat about that is the containers that you have may not be the same. So the CentOS 7.6 container that I tested here does not have the same amount of packages as the equivalent VM. So just bear in mind what you get is not necessarily like this other thing that looks like it should be the same thing. So the kind of options you've got for this, if anyone's a Red Hat fan, you can use S2I. Packer, like I said, is my go-to. I'm not a HashiCorp shell. Ansible Bender and Builder will work if you want to run stuff in a pure Ansible setup, if that's your thing. Or, like honestly, if you're just sitting there and thinking, this guy's telling me all this kind of complicated stuff, my use case isn't genuinely that difficult, just add, copy it in, run it, and then squash it. And there's tools that you can use to compress the layers down before you push them out. So, like, whatever fits your use case. It honestly depends. So, a quick thing about how do we get code into this? So the obvious thing is that you have the Docker file within your repository, and you essentially build the image around what you have. Not everyone does that. Like some people store stuff in Artifactory, so just pull it out of Artifactory, pop it in. There's no reason why you can't essentially replicate all the kind of CLI pipelines you have to build these images. It doesn't really matter. I guess that's kind of the theme of this talk. It doesn't really matter what you do. You're all special snowflakes. So additional configuration. This is something that's caught me out in the past a number of times, is that you have configured your application incorrectly, and you know it's correct, and your application still doesn't run. Why is that? Because there's probably other binaries and libraries and things that are configured differently somewhere else in your system. So if you've taken what you're doing on a VM, put it into a container, there is a chance, for example, boto uses completely separate configuration for how it handles certain things, a whole bunch of ways that it can load configuration out. And you have to be aware, what is it loading in what order, and what am I putting somewhere, and where is it actually going to load from in order for my application to work okay? So just like things to have a look around, say like, I downloaded this library, it relies on ImageMagick. Is ImageMagick working properly? I don't know. Maybe? Like, it's just the kind of things that may catch you up. So let's run it in a container. All right, so let's build that Docker image. What's happening here is a bunch of my really amateurish stuff. Kind of builds, pop some libraries in, looks mostly good, set the permissions correctly. Good. I'm going to tag, let's push it to my local hub because I don't trust the internet. Let's run it. And now I've containerized my application. Easy. Piece of cake. I copied the SQLite database in, if anyone's wondering why that magically happens. So how far have I got so far? I have a single container with port forwarding into port 80. It still uses that crappy SQLite database, and the configuration and the database are baked into that image, which is a huge no-no. So any changes I make to that settings.php will vanish because it's on an ephemeral file system. So I can't really update something within the application and have it persist necessarily, which is not great. So let's move on to Docker Compose. So I need to run MySQL. Let's run a big boy database. Let's put that in there. So this is essentially just a tool to run multiple containers on some kind of basic shared networking. Nothing fancy. Leads to other things, like making out on the top of a hill. Leads to other things. So traditionally, it's just based on development and testing workflows. So people use it to bring things up on their laptop. That's the common use case we see with developers, right? I've got this thing. I want to quickly test it out. Let's grab these community images and just to build a POC. And that's absolutely fine. That's great. But let's go through, what does that turn into? How do we move on from that? So let's do that. My script stops it. It's fine. You'll have to trust me. So let's stop the container I have. Wait a little while. Build another container image, because this is about building containers. So I'm doing it, honestly. It could be faked. That's why there's videos. So let's build another image, push it out, and now we're going to bring up MyBP and a MySQL container. And if I've done this correctly, those things will come up. It says importing. I'm actually waiting for it to come up. I was too lazy to change the message. MySQL takes a little while to come up. You'll see a bunch of garbage on the screen that proves that that has happened. And then I'm just going to import the same thing. So I installed it previously with MySQL, ran MySQL somewhere, dumped it out, put it back in. Not necessarily a realistic use case, but I needed some way to pop it in. So you see there, we've got standard compose logs. That is a database container. And if I reload this, you will see the MyBP container. Prove that I am not completely making this up. You can see things work, and you can see things being logged. So, all right, getting somewhere. We're getting somewhere. So what do we have now? We've got MySQL running in a separate container. I'm volume mounting configuration into it, and I'm syncing configuration files in. So essentially, I've got a copy of config and settings.php that I copied out after I initially installed it and go, OK, I've identified the values I need to update. It needs to look like this. So I'm just going to pop that in, and then I can bring the container up multiple times, re-injecting the same config because it's in a shared volume. But the shared volume is only local. So this still only runs on my laptop. And I've still only got one container for running the website, which kind of sucks. So I guess just to kind of go over some basic things, everyone, I am sure, by now is aware of what most of this stuff is. But Swarm is the easiest way to get a path to running multiple containers, since I can reuse, give or take the same compose file. There's a few changes. Kubernetes is the standard. We can't really fight that anymore. But as was lightly pointed out by Renata earlier, and I'll touch on later, not the be-all and end-all. For example, we run Nomad. Nomad has the advantage that you can schedule non-container loads on it, so we run Java jars directly. So we can schedule traditional stuff and containers at the same time using the same platform, which is really handy. But that comes at a sacrifice of a certain amount of functionality, so it really depends on your use case. If you use Marathon, I'm sorry. I've met a handful of people in my career that use it. None of them seem happy. It might be because I was their manager, but. And Uber Peloton came out, and I genuinely haven't looked into it too much beyond, it's a lot of stuff. It's a lot of stuff, but if you're at Uber scale or you're Google scale, then you might need something like that. But there's lots of options is the point. So let's look at Swarm. It's basically Docker Compose for more than one machine. So you have multiple machines in the pool, like multiple nodes, and there is the most generic load balancing diagram I could find, which is off the documentation. So stuff will come up and it'll load balance stuff between the pods based on very basic networking system. So I can do the exact same thing, and it should work, fingers crossed, with replicas. Wait, three? I really should have timed this. So, Swarm will come up. We've got some containers, got some port forwarding, brought some data in. Can I get through the rest of the demos in 12 minutes? We'll find out. Come on. I've seen this demo fail so many times. These sleeps are very conservative. So to give a preview of what I'm going to go through after this, just as a warning, I'm going to put it into Kubernetes, then I'm going to install it with Helm, then I'm going to install it with Helm with Consul and Vault, and then I'm going to set up Consul ESM and the Vault secrets engine, which I realize is very a lot of things to do to go through in that kind of time. But we'll see how we go. So this still works. And you can see there's multiple replicas of my BB. So we have one database container and 3 MyBB containers. All right, good. So we've got the configuration files injected as individuals as opposed to mounting the volume now, because you can't mount individual configuration files without Swarm. But we've still got a problem that the settings.php file, I'm injecting it in, any changes I make to it are gone. Ephemeral file system. So that's just to kind of illustrate that point. Like I said, repositories all up there. You can look at it, criticize it all you want. But you'll be able to see sort of examples and run-throughs of how this stuff pans out. So let's template this stuff. Kubernetes is Kubernetes. So container quick start. So a lot of this stuff kind of assumes that you are either using no configuration or using environment-based configuration. That's great. But if we want to bake configuration in, that has the ramifications that if you would have to build individual images for like development, testing, UAT, staging, production. So we want to kind of extract that stuff out of there, especially because if anyone gets hold of a container that's configured to set up for prod, bad things happen. So let's put that stuff into the orchestrator. So let's get the orchestrator to define what's being put in there. It means that we then have deploy time or update time control over updating those files. And we can make assumptions about when that application is being updated. And we can do fancy deployment things. So I've literally just dumped it into a config map. So let's take that PHP file. And a config map can be anything. Doesn't have to be any kind of structure. It's just dump random text. Let's just pop it in there. And let's pop it in there with some templated stuff. I will try not to go over, but I can, I promise. So let's stop the Swarm deployment and deploy it onto Kubernetes. So what kind of advantages does that get us? Let's run through the slides while that happens. So admittedly, nothing over Swarm for now because I'm running it on a single node. We get replicated containers still, but we replace Docker configs with Kubernetes config maps, which means we then have more control over how they're injected in. And that is where Helm will come in handy. Does that, come on. Dead still? Definitely should have timed this. Okay, so some of the templating that we're going to do. So all of these files are just JSON for the most part, or YAML, right? So we can template it out with any kind of language, the same as you would template out any kind of view files for a traditional application. There's endless choices these days. So Kubernetes has things like Helm, Case on it, all of this stuff. We use Levant, for Nomad. But there's a bunch of generic stuff as well, so it doesn't strictly matter what orchestrator you use. For example, JSON is also something we use to render out whatever you want. So it doesn't really matter as long as you can render it out as some kind of string that your orchestrator will understand. So Helm uses Go-based, like templating, as anyone will know. As Jackie pointed out, it's not, how to put this politely, there are issues with it. Like, do not assume that it is the apt-get of Kubernetes applications. Like cleaning stuff up, removing stuff, genuinely managing versioning and dependencies can be a bit rocky. Like Tiller is not the greatest at that. But it's great for off-the-shelf software if you want to just quickly get started. But the same with community images. For example, you can use it just for rendering templates without the actual server-side component of it, which is how the Spinnaker bake stage works. Customize, another example, if you don't actually want to use templates, that just works on an overlay override system. So I have my default chart. I just want to override this and this. Can works like that. And JSON it, which is basically JavaScript-based stuff because someone wanted to create a DSL for it. But it works. It works. Let's see. My demo worked. Haha. So, Kubernetes. Oh, no, nothing? No reactions. I guess. No one cares. No one cares. I've not shown you anything interesting. That's fair. That's fair. So how do we persist configuration changes? We need some kind of shared volume, right? We need some kind of shared file system for us to write back to, which regardless of the container paradigm, our application still relies on it, and yours might as well. So let's put a shared volume in there. We would need storage that's mounted per container in a pod, so we just specify stuff like that. Persistent volume claims is the easy way to do that. So I would like this kind of storage here. I'm going to request it. I will see if it's on the cluster. Boom, mapped. I'm going to skip over this stuff because I'm short of time, but there are a variety of options, some of which is abstracting the storage away, so it behaves generically. Rook has issues. All right. So delete that stuff and rebuild a file that doesn't have some of the configuration in it so that we can then pop it onto some kind of shared volume. So some of the key points about that, as I said, we're just configuring how that volume is physically mounted in. And then we essentially just end up with some values that we can template in. So that's the other advantage. So I can now template in where my database is, where my cache is, what some of my configuration values are. So we've taken this static configuration file, and it's now templated out so I can override what's being deployed into it whichever way I want. So now we've got dev, UAT, production, deployable stuff. I can provide the overrides as entire files or as specific values. Now we have persistent volume. So that settings.php file gets written currently to a local volume. Let's say you can set it up with an NFS volume. And then that will then persist in the background. Application writes, gets read all around. Obviously, there's ramifications for that. But let's get to why everyone was here. And I'm going to have to show in breakneck speed, actually updating this stuff on the fly. So ConfigMaps do not update reliably is the short story. There is seemingly no progress on getting that to happen in a reliable fashion. So you can do it with blue-green deployments. You can solve that at a deployment level, but actually solving that at the Kubernetes level is a bit rocky. So let's use dynamic configuration. Let's get something in the container that updates on the fly as we push changes to something that allows some kind of mechanism that allows us to watch for things that change, say, in a remote KV store, or some kind of secrets that change as we go. Consul Template is the most common way I found that's easiest to do that. Conf.d is a Kelsey Hightower project that does pretty much the same thing and plugs into a wider variety of backends. So, assuming that my Kubernetes demo worked, this will also work. Well, I knew this would happen. Actually, wait. And I was worried this wouldn't be useful. So we're essentially building something here, and Consul Template is going to be running in exec mode And that basically acts in, if anyone's familiar with supervisor, a similar kind of thing. So you can set it to watch a process and go, when I detect changes, then I need to re-render the template out. So I've got mine configured for Consul for KV and Vault KV. So I will look for any changes to this key value store in both places, one for encrypted secrets, one for plain value stuff. And I will read like say Apache, which in this case. So I'll bring that back up, and then I basically watch for changes and restart it as it happens. Theoretically, you're able to control the signals for how that works. Sort of works. But say that means that you could build an application that can change these KV values on the fly, and your application will change inside of the container, which in theory is kind of handy. I don't think I've even got enough time to play the videos. Damn. Well, I only have myself to blame. OK, so we have the same plain boring form. You can go around it. Looks like it works. And then at some point, I will open up Consul and Vault, I hope. There we go. Just to prove that they are actually running and things are actually happening. So basic port forwarding for now. I'm just going to pop into there. This is my first conference talk, by the way. I have learned a big lesson about not to do live demos, which I knew was my own fault. So I've got some of the values that you saw that I rendered out into the Helm template, popped them into here, and I've got credentials. So I've got the username that's configured in here, and I'll go into Vault and check that the encrypted password is in Vault at some stage. Password. And because this is all I'll get a chance to show, I'm just going to talk over what's happening now. So I'm going to build a final image. Essentially what this is going to be set up with is I'm going to use Consul external services monitor. So in the previous example, I'm manually injecting in where the database is and where memcache is. So I'm just injecting in like the kube DNS names, like it should be here, it should be here. But say in a realistic example, you're going to use something like Elasticache or RDS. So I need to physically tell it, like RDS is over there and Elasticache is over there. But because they're hosted services, I can't run a Consul agent on it. So I need to inform Consul in some way, like you need to go and look at this thing, which you can't natively monitor, but just like go and look at it and check that it is where I think it is and that it's healthy. So I've essentially set them up like that, and they show up as services in there. So you can set up node checks, health checks, depending on what you're actually connecting to. And then I can render those service discovery entries back into Consul Template, which is how this is set up. Vault, on the other hand, uses a secrets engine in the backend. So how that essentially works is there is a init container in it that will go, I need to get a Vault token. It talks to Vault, and Kubernetes will go, like, who are you? I'm like, OK, if you check based on the roles that I've been assigned that I am the forum software, and I'm allowed to do some things. I'm like, OK, what do you want? Like, I want database credentials. Like, great. You can have them. You're allowed to access this database for this amount of time, and I'm going to give you those credentials for, say, 2 minutes, because I don't trust you. I'm like, OK. So it gets that token back. Consul template acts as the Vault agent in this case and is able to pull credentials back, and will then basically just pre-populate them in. And at half-life for those credentials, in terms of TTL, so say I set it for 2 minutes, it's going to ask at 1 minute and go, I need to renew these because I know they're going to expire, so I need fresh ones. And depending on how your policies are set up, it will or will not get that. So it's kind of a break glass solution. You can go, do not issue any more credentials. Application will go, I want this. And Vault will go, no, you can't have it, and it'll shut down. So linking that into other kinds of ways to get credentials out of Vault is an easy way to cut off access for things to people, if that makes sense. All right, so just to show a final slide and skip over all of the things I agonized about, I will show the key bits, which is really this. So I've got credentials that look like random stuff. You can go in there, you can check that it works. I sleep for 90 minutes, 90 seconds. I can reuse those same credentials. Those credentials are bad. Vault has gone into MySQL in the background, wrapped them up. So those credentials are bad, but the application is handling that credential rotation for me with files. So I've not changed any of the application code. It still works. And I promise I will post these videos so you can prove I was not lying. Thanks to my former team, a lot of the stuff that they had to listen to me and the crazy ideas that I got them to build, this stuff is based upon. Thanks to Explore Tech, a local meetup, for giving me my first opportunity to speak, which which I apparently learned nothing from a couple years ago. Thanks to the London tech community for keeping me pessimistic, and the Toronto community for trying to make me more optimistic. And very special thanks to the DevOps Days Toronto organizing team and Seb for trying to coach me in terms of speaking, but they've provided a lot of support here and they put on a great event. I'm very grateful for the opportunity to speak here in front of everyone. That is the GitHub repository, like I said, where there is code, I promise. I've had many sleepless nights over trying to get this to work, but hopefully it wasn't all for nothing. But the slides are up there, so you can take a look at all the stuff that I skipped over. You can hit me up on Twitter. I'll be around for the rest of the event, so if you want to ask me any questions or tell me you spent too much time talking about the stuff that I don't care about, you skipped over all the important stuff. That is true, but so I apologize for that. But yeah, ask me anything. That's all my info. Thank you very much for being understanding, and sorry I went over.